Okay, and so now I'm bringing up some of the questions that I want you to do. So number 1 and number 2, and I think I need you to do 3 and 4. These ones are pretty easy. You won't be able to write the name for some of them, but I mean, you can Google them. So what I expect from you is HCl aqueous. You're always going to be reacting it with what? With something that's amphiprotic, H2O. What do I mean by amphiprotic? An amphibian can live on land and can live in water. That's why we call it an amphibian. This water is amphiprotic, meaning it can either donate or it can accept a proton. So when I'm looking at this, the first thing I have to decide is, okay, it's going to be an equilibrium. Is this going to be an acid or a base? This is going to be an acid, right? It has an extra hydrogen that it can give off. That's going to make water immediately a base. So when you're looking at what's going to happen, acids are always going to lose a proton, and bases are going to always gain a proton. So this is going to be the conjugate base, and this is going to be the conjugate acid. The acid always turns into the conjugate base. The base always turns into the conjugate acid. So rules. All right. When you see something that's negative, right, this one's a little bit of a difficult one to decide if you want it to be an acid or a base, but because it's asking you to find the conjugate base of everything, we know that all of these are going to act as an acid. Okay, so think about what's going to happen to this. It's already negative, and it's going to be losing another proton. What is it going to turn into? As a rule, most things that are positively charged or neutrally charged are going to be acting as acids unless they have 2 or more hydrogens. In that case, they're called polyprotic. So in this case, carbonic acid does have 2 hydrogens. If you look at number 2, where it's asking, write the formula of the conjugate acid, so all of these are going to act as bases, most of them are negative. Okay, whenever I see a negative, I'm usually thinking that it's going to act as a base. Why? Because it's going to accept a positive proton. Negative is attracted to positive. Positive is attracted to negative or wants to get rid of the extra positive charge. So I hope that helps you out. Okay, so I went over the idea of monoprotic versus polyprotic. So in this case, a monoprotic acid is hydrofluoric acid, and then this is acetic acid. There's only 1 hydrogen to give off, right? Polyprotic acids, they have more than 1 hydrogen to give off. The interesting thing about this, however, is that the first dissociation this happens around 99.999%, which means it's a strong acid. Okay, anything that dissociates around 99.99%, that's what makes an acid strong. The second dissociation is a weak acid. So when this HSO4 loses another hydrogen, this happens like less than 1%. So we say that it's a weak acid. And think about it. This here is the negative anion. A negative anion losing a positive proton, it doesn't want to do that. Okay, positive and negative attracts. So why would it want to lose the second one? It won't. Okay, well, it'll lose it, but a very minuscule proportion. Whereas with sulfuric acid, H2SO4, a neutral compound losing one positive proton is going to happen 99.999%. Okay, neutral and positive, yes, they're attracted, but it can easily be pulled off. So the first dissociation is a strong, it acts as a strong acid. It happens pretty much to completion, whereas the second dissociation, it acts as a weak acid and it happens only less than 1% completion. Okay, so for number 5 and 6, which I'm asking you to do for day 1, it says calculate the concentration of hydronium ions in each of the solutions. So this is, you're going to have to use, look at all the different formulas you're going to need. To give you a refresher, you can have concentration equals number of moles divided by volume. You can have the dilution equation, C1V1 equals C2V2. This one here, you're going to have a neutralization, and then you have to find the new concentration. And remember, it's going to be diluted because you're adding 18.6 milliliters to 24.8 milliliters. And then you have this one here where you have 2 hydroxide ions with calcium, and you only have 1 hydrogen with nitrogen. So with nitric acid. So how you're going to have to use some stoichiometry to figure out the concentration of hydronium in all of those ones. The same one here. You can find the answers at the back of the chapter. So we're in chapter 8. If you go all the way to the back of the, if you go to the chapter 8 review, you'll see the answers there. If you have any questions, let me know and we'll see what we can do.